So welcome guys to a new video, and in this video we are going to talk about the comprehensive problem, the review of this rotator mk1. So right now you can see the rotator. Inside there are two motors run by a dual edge bridge module, which is communicating with the Arduino mic nano, that is the nano, and through PWM control we are controlling these two motors. So this motor right here is the elevation motor, and the center motor you can see is the azimuth motor. So these two motors are actually controlled via Arduino Nano, and the sensor that we are using, which is this MEMS sensor, which is right there, and we are taking the feedback from the MEMS sensor going into the system, and we are deciding where is the north, south and every direction of a half plane. So that is the concept of this tracker, and we are successfully controlling this motor via command. Let me show you what is the current situation in the program. As you can see, we are back in the program computer where we are going to take control of this rotator. The rotator actually runs via 12-volt supply, and that is the rotator also connected via the USB connection as a serial port to this computer. And let me show you what the rotator is actually doing. So let's run the Arduino IDE first. So we are back in the IDE, and there is the rotator program that is inside the AVR, and through serial communication we can communicate with the rotator, and there are few commands that we can give it to via serial command, so that we can get the rotor control as well as the rotator data. Such commands are, let's say we want to debug if the sensor data is coming right now or not. So let's run the B command. So it is there to debug. So it will show me the raw sensor data that is there. The sensor is accommodating. If I try to move, you can see values are changing. So that is showing me the raw sensor data. So let's abort this program, and let's say we are in the monitor mode. Let's say we are monitoring the output. So you can see the left two digits that are there to showcase the current position of the rotator, and there is another two, you can see two digits. These two digits are there to show the error, and these two are going to be the putted instruction position. So whatever you put or whatever you targeted, that will show here. So let's say we want a position control. So let's say we want 20-degree elevation and 20-degree azimuth and 30-degree elevation. So we put 20 and 30 there, and if I hit enter, the rotator should rotate towards 20 and 30-degree azimuth and elevation. So let's hit enter. So let's hit enter and see. There you can see the rotator rotates and it gets to a 20 degree. As I said, there you can see 20 and 30, and this is the current value, and these two are targeted value. So we can see the rotator actually taking command, and rotator is stable. So through the communication, ID communication, serial communication, we can talk to the rotator easily. So that means rotator is actually working, and we can control the rotator via any serial command. So let's let's close this process first. So I have closed all the program, and if I go over to the terminal, and in order to communicate with the rotor, we need to have two libraries. We need to have rotor control libraries. Hamlib is a great library which supports lots of different communication protocol. In our case, it is a replica of rotator mk1. So we need to have EasyCom2 protocol to talk to the rotator. So to talk to the rotator, this hamlib library supports different kinds of protocols in its library. So we have to run the program. So right now we have the hamlib installed in our system, and the system path is also configured. If I can show you the system path, then if I go over to the system and go to the advanced settings, and if we go over to the system variables and go to the path, you can see the program file, that is the hamlib, that is being installed. So you have to install a latest model of hamlib, and we have to add this to the system path in the system variables. So after adding the path to the system variable, we can talk to the rotator. So that will talk to the rotator, but we need a tracker who's going to track the satellite and give the command to the rotator. So in that case, we have the gpredict, which is a well-known software that is used to track the different kind of satellites, and we have the rotator control. So via rotator control, we can easily, there you can see the azimuth and elevation. We can track any satellite. There you can see a list of satellites that I have selected. I want to track off. I can just click the satellite, and it will show me the position of the satellite. There you can see the position, and it will show me the azimuth and elevation angle. So I can track the system, and if I engage the rotator, that will put the data through a particular port, and that port via the library of hamlib can access to the rotator, and rotator should rotate. So our problem relies on the control of the rotator. We can manually easily control the rotator, as you have already seen in the Arduino IDE, but in case of communicating hamlib through the gpredict to the rotor is actually we are having problem right now. So let me show you what I mean. So let's first see I can paste terminal commands and run the motor or not. So in that case, I need to show you something first. So let's go over to the program files and go over to the hamlib, and let me show you two very important commands that we need to address right now. That is the rotcl.exe and rotcld.exe. These two exe file, this one rotcl, that is there to talk to the rotator via EasyCom2 protocol. If I address this, and I can manually put command to control the rotator, and this rotcld is there to also take control of the command, but through a TCP IP way. So in this command, in this exe file, I can directly give command, and the rotator should rotate, and via this we can control the rotator via TCP IP. In gpredict, we are engaging the rotator, and that gives a specific TCP IP protocol communication through a particular port, and that port is directly fed by this ROTCLD, and then we can easily control the rotator. So we can easily control this ROTCLD via command, but through this we are unable to control. So that is the our current problem. So let me show you what I mean. So let's go over to the terminal and let's try to rotate the rotor via the normal commanding prompt. So let us first see our COM port is free or not. So in our rotator that is connected to COM7. So let us see first our COM7 port is what is COM7 port and what are the parameters as by default set it in. So let's say we have to put mode COM7. If we put this instruction, that will show me the current status of the COM7 port. There you can see the baud rate is set to 9600 and the data bits is 8, timeout is 1, and the stop bit is 1, which is exactly what we want. So we can see the COM7 port is open, and we can communicate with the COM7 port, and there is nothing stopping us. So let's try to run a particular command to talk to the rotator via command prompt. So in here I have put a command which is addressing the exe file, where is the location of the exe file, and followed by the M, which refers to the protocol. So we are talking through the EasyCom2 protocol. So we have addressed 202, which is corresponds to EasyCom2 protocol in the Hamlib library, and then we address the port which is the COM7, and there is the baud rate, and VVV is for the information, whatever the we put in, it will show me the debug, all the debug outputs. So if I hit enter, and there you can see the rotator, this system engages, and you can also see the EasyCom2 protocol is being printed out. There is the version, and that is stable, and it wants right now rotator command. So let us give the rotator command, which is a position command P, capital P, followed by elevation and azimuth and elevation. So let's say 60 degree azimuth and let's say 30 degree elevation. So if I hit enter, the rotator should rotate, because we have established the connection, we are talking to the system via serial communication, and Hamlib supposed to do the signal via EasyCom2 protocol. That means if this rotator rotates, that means we are in the correct path. So let us first hit enter and see what the rotator is doing. There you can see rotator rotates, and it shows some values that it does, and there you can see it is addressing the 60 degree azimuth and 60 degree elevation. That means our rotator command is actually working. So we can talk to the rotator via normal command prompt. We don't need to put the Arduino ID and then put command. So via this we can easily talk to the rotator. So that means the rotator is actually working right now. But the problem is that right now I am having, let me show you first. If I terminate this terminal, so let's directly terminate this, and let's see our COM port is free or not. Let's say mode COM7. So let's see what is COM7 is doing. There you can see COM7 is free. So now we are going to run a different command, which is officially the website intended us to do. So let us say first go over to copy this code, and let us paste the code right there. So this addresses the ROTCLD protocol, followed by the there you can see the server host, and there is the port. So this runs as a rotator daemon. So we can daemon control this rotator. So if I press enter, there you can see the system is running. So you can see it is running. So we have to minimize this, and we have to let it run in the background. and let's go to the gpredict, and let's go there and go to the preference, and let us see what are the ports. And there you can see the host that is being there, that is the local host that you already have seen in the program. That is the host and that is the port. So rotator mk1 is the rotator that we are particularly interested in. So let's go over to there and click OK, and let's try to control the antenna control. So let's go, and there you can see by default 180 degree azimuth and elevation. We can we can change everything. So let's say q100 we want to track, so let's put track. That means the command is being refreshed, and if I engage the rotator should rotate towards 258 degree azimuth and elevation of 18 degree. So but what happens, you can see what it will do. If I put enter, engage, there you can see it goes over to the 0 direction. And if we go to the terminal and see what are the values being printed out, there you can see it gives the rotator command. You can see azimuth and elevation of, you can see azimuth 258.2 and elevation 18.2 as we intended, but rotator refused to rotate and it goes over to the parking position. So there is something wrong with the communication, I think. That is why it is doing this kind of thing. But we can get the information, whatever the gpredict or the any other tracking software doing, we can get the information. You can see it is trying to rotate, but it fails to. And if we go over to the set command, you can see the EasyCom rotator set position called this value and this value. We can get these two values from the command window, prompt window. So what we can do to communicate, we know how we can rotate the rotator, and we also can get the data from the this prompt. So I don't know what to do, but we have figured out a hard way to do this. So what is the hard way? So what we have done, I don't know any programming or anything. One of my friends know some of the things, and through the help of chat gpt and such, we have configured a program which runs the rotcld inside the python terminal, and in that way we can get it to print whatever it outputs in the terminal. So we can then later put an additional programming which debugs the particular code line that we are interested in, which is in our case this line, this EasyCom rotor set position, this line we are interested in. We just have to trace this line from the command window and take these two values, the two separate values, and we have to put the other program that is there to position control in there. We have to give it the P and we can control it via this hard way. So this program is actually runs, and it can take the data and print it over our system. So let us first see our COM port is free or not. So you have to make sure your COM port is free, otherwise you will get the error message. So let's say mode COM7. So if I put this, it will show me yes, the port is actually free. And if I run this then in the Python, we can get the same thing. You can see it is there, you can see it is running in the background, and that is how we can get the data from the rotator, and then we can get to the rotator to rotate. So this is the hard way, but we cannot directly control the rotator via gpredict. So that is the problem that we are having right now. So that is the project update, and it's been a long video. I hope you have watched it from the beginning to finish and can connect to the problem. So let me know if you have any solutions for this, why the gpredict refused to give particular command, and why my rotator is not taking the command. So that's it for this video.